This video will just be the 3 examples left in 3.3. If you want, you can try them on your own and then just check my answers, but there'll be a lot of me telling you to pause and try things on your own. So our first example here, we're looking at a linear model to predict the price of a particular car from its mileage, calculated from a sample of 38 cars. The resulting regression equation and correlation coefficient were, oh, that's a typo. The resulting regression equation is this thing. So I'm usually pretty lazy and just glance straight to this. Like I said, I will give you your actual regression line. And our first question asks us to interpret the slope. So remember our slope. You can go straight back to the other page. That negative 0.0151 is our slope, right? And we're looking at change in y over change in x. So I'm going to let you guys have an opportunity to pause the video now and figure out which answer choice you believe is correct. Okay, so for this one, we can immediately get rid of A because it has the y-intercept in there as the value instead of the slope. And then we can see the difference between B and C, another easy one. We have increase or decrease. Since we have a negative slope, increase is out. And then we get down to the 2 questions that students usually get down to. These are both correct, except for they have different x and y's, right? They swapped what our x and y variables are. And unfortunately, we don't know which is x and y from the regression line, but there is a keyword here to help us out. The fact that it tells us to predict the price tells us that we are trying to predict that, which is our y, and that means mileage is our x. So we need to say for every 1 increase, right? These go together, for every 1 increase in x. So for every 1 increase in mileage, our answer is C. And then we move on, and we can do part B. Again, I urge you, pause the video, try it on your own, and then come back. Okay, so we're being asked for a residual, which is that little e. We know our formula. As soon as we see that is y minus y hat, our truth minus our prediction. And we can translate the rest of what was being given to us. We have a price of a car, and we had the number of miles for a car. And since we did that good work up in part A, we know that the mileage is our x. This is our observation for a particular car, and the price is our y. Now, we don't have y hat, right? That's the one missing piece for this formula. What the heck is that? Well, this is a 2-step question. Step 1, we can figure out what the heck y hat is. If you recall, finding y hat is just about plugging in our x to the regression line, right? In fact, this should have a hat on it in that regression line. We have this y, but we don't need it. We're going to use the line to predict our price when the mileage is 50,000. So we'll take this, our intercept, and subtract off 0.0151 times that x. And we'll figure out what our y hat is. And we get our y hat. So we would have thought the car would cost $23,601.15. Now don't get excited here. I have a lot of students who will box this up and think they're done and forget that the whole point of this was for us to be able to do the second step to find the residual, which was the question we were asked. And we know our E is the true value, which was that 24,000, minus our prediction, which is $398.85. That's how far off we were.